Vanakkam, Namaste, Namaskar. Welcome back to Jalprayag. I had mentioned that I'll be doing one more video on rocks and wrecks, but I'm changing the topic a little bit, which is actually relevant for the subject which I'm going to take next. So I'm going to do a slight detour. Let me go on a topic which is by itself a subject, but I need to take this because the symbols of rocks and wrecks and your chart, all of them are related to this one concept called tides. So I'm going to take this tides, and once I finish this, you will realize that why I want to do this before I go for your rocks and wrecks symbol. It's got a lot of relation here and the chart work also. So let us go into this. Let us try to understand the very basics of tides. Uh, you should realize your tides are not only a concept which is needed for seafarers. This tide is there even before you joined sea also. So as any common man, it is a part of a nature which goes on with its cycle. And as far as the reasons are there, it has been for maybe thousands and years, whatever is the creation. And it'll be there for in future also. So you need not be a sailor to understand this. Even a 10th class student, I think if I'm not wrong, it'll be somewhere in your 8th or 9th class syllabus in geography. This is being taught. So the subject is not only for seafarers. What is a tide? A tide is nothing but a vertical rise and fall of water, and that will result in a high water and low water. And you will see this effect if you just notice in this picture up here and this picture. These two pictures shows you that how water can go up and down in the same place. Now, why is it this happening? There'll be a lot of reasons. Let us not go into all of them, but let us see what is significant. For me, it is the gravitational pull of sun and the moon. Your moon is all closer than the sun, so it has got more influence than the sun. Your gravitational pull actually is there in all the objects. Whatever objects are there, it is there. It is on the humans also. But water being a fluid, and you can very easily see the change, so it is visible and pronounced. Before I start into the actual tide, I'll just quickly show you the sun and earth relation. That means what is happening with your earth and sun uh, for a year. There's a small reason for me to do this before I get into it. This part of topic will have some effect on the tides, but not that much, which I'm going to discuss a little bit later. But still, this also will have. Why? Because when the Earth rotates around the sun, sometimes it is closer, sometimes it is far away. So that will also change. So I'll leave that, but I have a reason why I want to show this. So let us see what is going to happen in a whole year. You will realize that the tilt what your Earth has got, that does not change its direction when you look from space. And this tilt is the reason for all your seasons on the Earth also. Uh, we all know there are mainly four seasons which we normally talk about. So it's your summer, your fall or autumn, whatever you want to call it. Then it is winter, and then is spring. You can see I've made the spring word spring bold. I'm going to show you an animation also, and I'll tell you the reason why. The same thing I'm showing you. Let me put the sun or the star at the center. I'll show you the earth with your axis tilted. And in this condition, I'm looking at a northern hemisphere part of it. So you see that direct sun rays will hit on the northern hemisphere 23.5 degrees, and this is what is called your summer solstice. After a quarter, you will see sun's rays might hit on the equator, so it is called your equinox. So this is a fall season after summer. Then comes winter, where the sun's rays are hitting 23.5 south. And then again, you will come to something called vernal equinox. And I put the spring once again here. Okay. So I'm going to refer this a little bit later. This is something to do with only the seasons. This is a spring season. Let us look at moon motion. Your moon revolves around the Earth approximately 28 days, 4 weeks. Each week is a kind of a prominent phase of moon. For us, this is a kind of extreme, so we'll take these only 4 phases: new, first quarter, full, and then third quarter. Your new and full, they are also called as inline phase. The reason being your Earth, Sun, and Moon are inline. That is the reason we call it. And then the quarter, which is called as quadrature phase, because when you look at the orientation, the Sun, Moon, and the Earth, they will form a right angle. So that is the reason it's called quadrature phase. Let us look at a animation again here. I'll put the Sun quite far away. Let us look at the Earth. How do you see this and visualize? I will have to go to space, top of the North Pole, go to the space and look down. That means when you look down, you will see the North Pole. That is what I've given as a small circle. I put just a person on the Earth just to show you. I'm going to put this moon, which is somewhere here. Moon doesn't have its own light, so it is going to reflect. The sun is going to always light up half of the moon. Now, the person standing on the Earth right now in this condition is not going to see the lit part of the moon. So he's going to see only the dark side. So that is why this is called your new moon Amavas. Inline phase as well as conjunction. This is the name used. After 7 days, what is going to happen? Same way, the moon is still lit half, and this time the human can see half of the moon and half is dark, so it is called your half moon, quadrature. 7 days more, this time it is lighting the half of the side which a human can see, so it is called your Paurnami, full moon, inline phase, and it's called opposition. The reason, your moon and the sun are in opposite direction of the Earth, so it is called opposition. Then later on again, you will have one more half moon phase. So you will see this. So this way it completes a full cycle. Why you are interested in this? You will see the tides which are generated in during the inline phase. They are given a name called spring tides because there's a combined effect of the sun and the moon. The pull is quite strong. Okay. Then what do you say in the quadrature phase? They are called neap tides. Again, spring tides, and again, neap tides. So in one lunar month, I will have 2 springs and 2 neaps. So what happens in springs? The pull high water is quite high, and the day you have high water very high, low water is going to be very low, and the neap tides will be in between. It will not be that extremes. Okay. So I'm going to show you same thing in picture. Let us say this dark blue color water is the pull because of the moon, and sun's pull is your light blue. So both of them are helping each other. So I have greater tides. Then what happens during neap? So please see here. This time, I'll just go back one step. You see, the dark blue was looking towards the moon and the sun together. But now what happens is the moon is in quadrature phase with the sun. So you see the pull is different. So there will be some cancelling effect. So the tides may not be as strong as what you saw in the springs. This is the difference between your neap and springs. Let us look at one more feature. Why do you have this high water and low water daily? So that is related to the Earth's rotation about itself. So you know Earth rotates about its axis, moon axis. So I'm going to show you that. Let us say that you are right now in this particular stage. Let us say inline phase of your spring tide. And I'll put a person here. What will happen after 6 hours? So you will see that after 6 hours, the Earth would have rotated around 90 degrees. So he has gone here, the man has gone here. The water is still inline phase with your sun and moon. So now what you will see is low water. And again, it comes back to opposite side. Again, you will have high water. And then again, quadrature, you'll have low water. So remember the reason why we have 4 tides, that means 2 high waters, 2 low waters in a day, is this the rotation of your Earth about itself. So normally they say around approximately 6 hours duration, but it will not be 6 hours. There will be a change. That is something deeper. Now, with all this known, you should realize when you consider your observers as stationary, so you see your high water and low water. Basically, water is not created or destroyed. It is just coming from a different place. You call it transferred from a different place. That is how it is told, considering your observer as constant, just like your sun rising and setting. So if a place has got high water, there'll be one more place which has got low water. Basically, there'll be 2 places of high waters and 2 places of low water at the same time on the earth at any time. Any time you take, this is what is going to happen. I said new moon is conjunction, full moon is opposition. And I even told lunar month, 2 springs and 2 neaps are there. Now, what the hydrographers do, they sit and study and do measurements. They take some important ports normally, and they record every high water and low water for, let us say, over a period of an year. They might take it for a year, maybe more also. And what they do is they will check all the springs. During the springs, I will have quite a high water, quite a low water. All the springs they will take, and they will see which one was the highest one and the lowest one. They will take a couple of days here and there, adjacent to that highest values and the lowest values. They will find a mean, and then this average values are called mean high water spring and mean low water spring. This is tabulated and given to you in the tide tables. They will do something similar to the neeps also, and they will give you something called mean high water neap, mean low water neap. These are some average, that is what is called mean high water or mean low water. It's a mean. What is the use of these 4? These 4 are quite important for you in all your tide calculations and interpolations. Okay. And besides this, they do measurements and they give you a few more, 3 more, they can give you data. Lowest astronomical tide, LAT, highest astronomical tide, which is HAT, and then you can have something called mean sea level or mean tide level also. Now, something important for you in chart work, your LAT plays a very important role and has got a name. All of you should know that it is called chart datum. This is your chart datum. Now, what is so important about chart datum? Chart datum is used as a zero reference in charts for measuring 3 items or 3 readings, very critical readings. What are they? That also you should know. So one is your charted depth, second one is your height of tide, and third one is called your drying heights. Okay, these are all measured from chart data. Then where is the height measured of some objects, let us say lighthouse and all? They are not measured from chart data. This is one common mistake which I find whenever I ask people, say that also is from chart data. No, actually no. They are measured either from mean high water spring or HAT. And this is mentioned to you usually in your chart itself, that what is the reference level you have done. There are some maps which are land-based or shore-based maps where they might use mean sea level also. So please be careful about the reading from which it has been taken. It's important for you before you cross a bridge or something. I'm going to show you pictorially these 7 characters which I had just written to you. I'm going to show you. I'll start with LAT. Okay. Then this can be called as mean high water spring. This is mean low water spring. Then you have the neeps also. Besides this, I have something called HAT. So I've shown you 6 characters here. The 7th one I'll show you in the next slide. You will see this is the hierarchy. So from LAT, this is the general hierarchy, how it goes. Now, there's something else which I will need during my tide calculation. So I'll tell you right now. They normally tabulate one more thing, which is called your difference between your high water spring and low water spring. It's called spring range. And then you have something called neap range. This is also used in your tide calculation. So we'll see that later right now. I'm going to modify this diagram a little bit because I'm going to show you much deeper the measurements. I need to show you all the measurements from where it is taken and how it is taken. I'm going to take let us say, a small piece of rock, underwater rock. So if I want to measure the depth of this, I will measure from LAT and I will call this charted depth. Now this is very important. Why? Because when they make a chart and give you the depths on the chart, they're all called as charted depths. So this is very important, is charted depth. Okay, they are not anything else, charted depth. Now your LAT is a reference for multiple readings. I've done one. Let us look at one intermediate case. What is the meaning of that? The rock which I've shown you here can grow up. It can come up to the LAT level, the green line or the reference point. Okay. In that case, that is called as a rock awash. This is also a symbol. Please remember, I'll show you this later. The same rock can grow a little bit more also. And if it grows more, it is usually in the chart given as a green color and it has got a name called drying heights. So it is a height. Please remember, this time it is not a depth, it is height. So when I had listed what are the three important characters I can measure from LAT, it was charted depth, drying heights. Then the last one was height of tide. Let us see where is the height of tide. I marked the star on the LAT. Why? Because it is very important. Okay. Let us look at height of tides. See, from LAT, if I measure the height of HAT, that is also called height of tide. I can measure it MHWS. Similarly, all of them. All these 5 lines, what I've shown you, all of them are height of tides. Okay. So I've shown you the 3 characters which are used from your chart data. Let us go a little bit further because I need to show more. A rock or a hill, whatever, can grow more than your LAT also. So whichever part is below your LAT or at till your LAT, it is usually called your depths. So that is why these are called depths. Anything which crosses LAT and up to MHWS, they are called your drying height principle, and all of them will be shown with green color in your charts. Okay, they are all underlined. Please remember, underline is a very important symbol. Why this underline? You can look at the previous video. There I've shown you an example of drying heights. Then what happens to the same land or the hill which is grown beyond MHWS? This is the color which is quite popular. I have marked even the lighthouse with that color because I'm going to refer it to some uh, level from which I'm going to measure. And I think you can guess it's the same color. So whatever I measure of a lighthouse or a land or a hill, whatever is there, I always measure from MHWS, and they are called your charted heights or charted elevation. They're all measured from. And so this is also one height datum, and I'm going to mark a star here because it's important. We will not stop here. There's one more reference level. Let us look at some artificially built structures, which is just like your, let us say, power cable, or you can have a bridge also. These need some vertical clearance or height. So that is measured from HAT. And it is also a star, is important datum. It's also called as height datum and is called vertical clearance. This is one of the most important slide you should remember because all your calculations, everything is based on this. All your symbols are based on this. The chart is based on this concept. One last, when you take average of the 4 characters called the mean, right? Mean high water spring, mean low water spring, and for the NEAP also. When you calculate the average, it is also called as mean sea level, can be called as mean tide level also. This same picture which I've animated is available to you in your books in a fixed format. There's no animation. So you can see this is approximately very similar to what I had shown. You will find this in NP5011 also, the chart symbol. Now, the reason for me to do this before I go to rock and wreck, uh, please remember your rocks and wrecks, both of them use the concept what we have just seen now. They use the concept. They use the concept of something which is a depth principle, something which is a drying height principle, something which is above your MHWS principle also. So that is the reason I had to do this. A lot of symbols are based on that. Sometimes it's color coded also with that in your symbols. So that is the reason I did. I'll come back on the next episode with your chart symbols of your rocks and rocks. I'll be using the same principles. At the same time, this video will help me also to continue on the tides topic. So keep watching Jal Prayag. Until then, Vanakam, Namaste, Namaskar. Until I come back soon with a new one.